This is the third session, right? Okay. So, what do you guys understand the difference between categorizing and discretizing? Have you gone through these two concepts before this in machine learning? Anyone?
No, no.
See, because category is also discrete, right? Category is not like a continuous variable,
Right.
and discretizing is also discrete, like it is separate, it's not again continuous. So what is the difference? Anyone, any guesses?
In this script, ma'am, we'll get the numeric value. I think so. Regarding regression, we'll get
Come
the
again, please.
numeric value something.
In category, we'll have yes and no
Category,
type,
In
and in
category you may
discrete,
have
we'll have
yes and no,
numerical
okay.
values.
And in
In discrete,
discrete,
we have numerical values like 1, 2, 3.
yeah, numerical values, it is possible that you can have numerical values.
Yes.
So then what is it? The difference is between, even though it is categorical in nature, it has a quantity associated with it, right? But that is not the case with categorical. See, if I feed a certain number of images for cats and dogs, and now I want my
hmm,
algorithm to categorize a new picture or image, whether it is a cat or a dog, based on the training that I gave. So it is categorizing, right? But this is not discretizing, right? Although
hmm,
discretizing also has a range, a specific range, but it is quantitative in nature. For example, the grading system. Suppose I grade you, say if you get 90 to 100 marks, I mark you as A grader. If you get 80 to 90 marks, I mark you as a B grader, and so on and so forth. So this is also categorizing, but this categorizing is associated with quality or quantity?
quantity,
Quantity.
quantity, ma'am.
Quantity, right? So this is what you call discretizing, right? So this is the basic difference between categorizing and discretizing. Do you understand right now what is the difference between category and discretizing? See, both are
Ma'am,
discontinuous. Both
could you
are
come again, please?
okay. See, uh, just don't focus on the screen right now, just think. I'm talking about what is the difference between category and discretizing. See, both the data sets, in both the cases, you have distinct sets associated with them. See, if it is a category, it can fall in A category, B category, C, D, right? Even if it is discrete, it has the same scenario. So what is the difference between them? Category is qualitative in nature, while discretizing is quantitative in nature. If you are talking about ABCD grades, in that case there is a sense of numerical value associated with it, right? For example, ranges of numbers. For example, if I say that 1 to 10, this range will be counted as one grade, where 11 to 20 as second grade, and so on and so forth. In that case, you have a number associated with it, and a range of numbers you have made as a discrete set, wherein you will classify your any aspect associated with your model, right? So that is also categorizing, but that is quantitative in nature. Do you understand? For example, again, if I say that my BP is say 120 by 80, okay, that is a normal. So suppose the systolic one 120. If I say that, okay, if it may vary 120 to 130, I will say that the patient is normal. 140 to 150, I will say slightly on the higher side. 180 and so on, I will say that the patient has a very high BP, for example. So if I have to take a medical examination and I want to judge on these criteria, then basically I am demarcating a range for which I will classify whether the BP is high, medium, or low, or normal, right? So this is also categorizing, but it has a certain value associated with it, numerical value associated with it. So this kind of categorizing is discretizing. Do you understand now?
Yes, ma'am.
Yes,
Perfect.
ma'am.
Okay. So now coming to what are nominal and ordinal variables. Okay, so in categorical you may have nominal variables or ordinal variables. What are nominal variables? Nominal are those variables which are having no order associated with it. For example, the same example, if I quote, if I have say thousands of images of cats and dogs, right? So and after training my algorithm, I show a new picture to my machine, and it has to predict whether based on its training set, the new image is that of a cat or a dog. So is there any hierarchy or order associated with it? Is there any ranking associated with it?
Not really.
No.
No.
Right? So that is called nominal variable. Now, if I say that, okay, there is a order associated with it, or there is a hierarchy associated with it. For example, in this example on the right, you can see that this is uh, like a rating: excellent, good, bad, right? This has an order associated with it, right? Or the ratings that you do, right? 1 star, 2 star, 3 star, 4 star, 5 star, all these ratings that you do, these have a certain order associated with it, right? So any degree associated with it or a certain hierarchy associated with it, when that comes into picture, then it is called ordinal variables. For example, there are 5 grades: A, B, C, D, E, or F, and among these, A is the most superior, B is second superior, C, and so on and so forth till your F grade. So there is an order associated with these grades, right? So now it is a ordinal variable, this is not nominal variable. So do you understand the difference between these two categorical variables, nominal and ordinal?
Okay. Yes,
Yes,
ma'am.
Yes,
yes.
ma'am.
Okay, now coming to the second one, the numerical one. Again, discrete is already understood. What do you mean by discrete? It has a range associated with it, right? And continuous, unlike discrete, it is fully continuous. There is no boundary associated with it. It can take any value, right? So, for example, height. In this example, height of a person. A height of a person can be any random value. It does not have to be a, discontinuous, discrete range, right? But if you have to count something, for example, the number of visits, right? So it is a number. It's not. It cannot take a fractional value. So it is not continuous. It is a discrete value, or discrete mathematical function, DMF, any such value or counting that you do, these are discrete values, these are not continuous values. But a height of a person can be some fraction also, right?
Yes.
Theoretically it can be any continuous value, right? So this is the difference between discrete and continuous. Do you understand this so far?
Yes, ma'am. Ma'am, Likert scale will be in ordinal, no? Likert scale. When we are ranking between 1 to 5.
Yes, yes.
Yes.
When you are ranking between 1 to 5, it is ordinal.
And one more thing, ma'am, when you say continuous in numerical, there is no bound lower or upper height on that, right? Anything can be continuous in numerical sense.
Yes, theoretically, yes.
Right. Okay.
Madam,
Yes.
there was one question in week 2 assignment. So in linear regression, the output is continuous and continuous with some finite range.
Okay.
So actually, it should be within finite range only, na continuous. But
Why do you say that?
in linear regression, the output is continuous. That was one option, and continuous and always lies in finite range.
Why do you say that? Why do you want the range to be finite? When you say finite, it has a particular boundary associated with it. Finite
Okay.
means it has a boundary now. It can be counted. And when it's infinite, it does not have a boundary or restriction associated with it. So when you say finite, do you know the proportion up to which your data set can extend or your linear regression value can extend? Technically, when you write the range or domain in your functional value or variable, so what do you write? X belongs to R, right?
Yeah.
Hmm.
So do you put a limit on that R, that 10,000 is the maximum value or some finite number is a maximum value?
Okay.
Yeah.
Not really, right?
Yes, yes, I got it.
Okay. Okay, so moving on. This is the fifth question in your first assignment.
Ordinal values
It
B
is
answer.
ordinal. It is ordinal
Ordinal.
Why so?
because
Heads are there, no? So
grades are
we can
there.
compare.
Hierarchy is there, ma'am.
These are grades, these are
Order.
categories, no numerical values associated with it, so it is category,
Hmm.
not a quantity. Also, within category, it is ordinal because it has a order associated with it, right? Yes. So, coming to the types of machine learning. So, the classical types of machine learning are basically three types: supervised learning, unsupervised learning, and reinforcement learning. So, by now, probably you have some idea of these. So, can someone differentiate between these three categories? What do you understand by it on a preliminary level?
Yeah, ma'am, I can try.
Okay.
Supervise means that it's like teacher, wherein like you have some input and labels defined to that input, that this is this. For example, when you submit some images of a cat, you specifically tag it with a cat
Right.
training data. So that means it's supervised.
Okay.
So like a teacher, you are already providing information what this data is, labeling it, and that's called supervised. That's what I could understand from videos. Unsupervised is like where you don't supply the labels, you just supply the input, and ML algorithms automatically identify certain patterns or certain information from that, try to inference what kind of data it is, and then groups it into different categories or ranges or whatever like the algorithm purpose is. And then based on that, it will then start predicting the future predictions. And reinforcement, I could understand because there was not much information available. Learn from the past. Like if there is any past information available, you learn from it. You reward a algorithm if it predicts correctly, and you penalize a algorithm if it does not predict correctly. This is what I could understand. I don't know about reinforcement too much, but this is how it is going to happen. We don't know.
Very nicely said. So, like he said, supervised means you are technically providing labeled data. You are providing the inputs and you are also providing the labels associated with the inputs. That means your x variable value as well as your y value, your dependent variable value, which you are going to predict, that also you are feeding. So basically you are feeding the input as well as the output as a training set, and after that training now you are feeding new test data, only inputs, and seeing what outputs it generates, right? So that is what is called supervised learning. Here you are already tagging your inputs with the outputs so that it learns firstly, and then once it learns or trains itself, then you provide only the input to see what is the output that it gives, right? In unsupervised case, on the contrary, you do not provide any labels associated with your input data. That means you are providing only the input data as your training set. There is no output tags or labels associated with it. And depending on the pattern, it is clustering your data and segregating them on different categories or bases, right? And on the basis of this learning, it is now giving you an output. For example, if you have to see here, you can see some blue dots and some red dots, right? There are some clusters.
Yeah, correct.
Right. So, depending on the similarity of the colors or the pattern associated with it, what your machine does is maybe segregates on the basis of some virtual boundary, right? So, now if you have a new point somewhere here, right, and that has to be predicted, what is the color of this point? What is most likely that your machine will predict?
Blue.
Blue, right? Is there any doubt or hiccup here?
No.
No. But did we provide any label data? Did we tag the
No.
data? That this
No.
one is blue, this one is red, this one is the boundary, this is the line. Did we provide any output associated with it?
Not really.
Not really. But the machine can still predict based on this variety of data and clustering. that this point is most likely, highly probable to be blue colored, right? So, this kind of learning that your machine can show is called unsupervised learning. Here, you are providing unlabeled data, untagged data, and your machine is learning on the basis of similarity, certain similarities associated with your training set, and it is giving you the output. So, although the training is happening in both the cases, but here the training is happening on the basis of labeled data, whereas here the training is happening on the basis of similarity generated on the basis of pattern of the data by the machine itself, not by the user or you. Okay, and reinforcement altogether is a different way of how you train the machine. Here you don't just provide the inputs and outputs, but you also have a pattern, like you calculate the loss function, and you have a system of rewards. See, if you have improvement in the loss function, what do you mean by improvement? The error value should be minimized, right? So if the error value is minimized, then it is rewarding. Okay, and if the error value is increasing, then it is penalizing, or some system of reward and penalizing if you do that. For example, this is a very pertinent example in the case of games, right? So if you see, there are certain options that you click and that might deduct your points, and there are certain things which can earn you points in games, right?
Chess
so
games.
so it is a pattern that is, that teaches you gradually that what are the things to be done and what are the things not to be done, right? On that basis, the machine learns that, okay, these are the ways on which this should be approached, or this is the way the model should be trained, or these are the variables that are taken into consideration, or these are the variables either not to be taken into configuration, or these are the variables which are to be given less importance or less bias or less weightage, right? So far so good, understandable?
Yes.
Yes, ma'am. Yes, ma'am.
Okay, so these are three different forms of machine learning types in the classical sense. So nowadays, people have such categories like semi supervised learning. There is deep learning, in which you have a lot of neural networks and all, but we'll not discuss that right now. So far, we will be focusing our attention on these three.
Excuse me, ma'am.
Yes.
Ma'am, I want to please once more give another example for unsupervised learning.
Okay. Repeat this part.
Yeah, I want to understand understanding it through this example.
Clustering is the only algorithm of unsupervised learning. Any other apart from that?
Basically,
Anomaly detection.
yes, go on.
I saw it in the book. Example of unsupervised learning, there was clustering and anomaly detection, and for supervised learning, there was classification and regression.
Classification also come in unsupervised learning.
No. For supervised learning, there was classification and regression, and for unsupervised learning, they said clustering and anomaly detection.
So, what do you mean by anomaly detection?
I don't know. I just read it in the book. I didn't read much further.
Okay.
Okay, to answer Abhishek's question, ma'am, may I try?
Go on, please.
Okay, because I read this as an example. Suppose there is some data with the company. They don't know what information it is there in that data. They want machine to learn from the data. So what the machine will do is, machine will try to understand the data by clustering. They will start clustering some data. For example, there is a data of images, which has images of dogs, which has images of cows, which has images of other animals also. So when you will give data to machine, what will it do is it will try and look into the shape of the cow and will try to match with the shape of the other cow's photos and will cluster them as a cow separately. And then it will try to find out images of one cat and then try to compare it with other cats, because cat has certain, say, mild mustaches and some different type of eyes, different types of hairs and things. So it will try to segregate the data into a different clusters. So that clusters will start coming out of out of that input data, and that is called clustering in a very simple term.
Okay, sir. To most extent, I am able to understand this. Thank you.
In this case, somebody has not input the data that saying that this is an image of a cat, this is an image of a dog. Nobody tells the machine. Machine tries to find out the similar attributes in that group and group them in separate category and or a cluster.
Okay, okay, sir.
Okay, so here, like he said, it is, input is provided, but input is not tagged when it is provided. So you are giving the input as a cat image or a dog image or a cow's image, but you are not tagging it as a cat's image or a cow's image. It is itself reading the similarities amongst the images. Then it is unsupervised learning. You are not tagging it as a particular name or a tag associated with it.
Okay, thank you.
Is there any more doubt here?
No, ma'am, thanks. I have got it.
Okay, good. So now that we've understood this, we will move on to the 6th question in your first assignment. Can someone go ahead and answer this?
So, ma'am, I learned it from one YouTube video. Wherever there is a robotics things, just mention reinforcement.
Reinforced learning.
No, but that is a very crude way. But then why? I would like a logical answer here.
It is learning from the experience.
Exactly. It is learning from the experience, right? You are neither supervising it with some tag data nor providing it a pattern to read itself. It is reinforcement learning because it is learning from its past mistakes or experience, right?
Yes,
Is there any doubt here? Because we discussed, right? A gaming example also I gave you for reinforcement learning, right? So I hope this part is clear. Anyone, any doubts here in this question?
No, ma'am.
No.
Okay. So then we will move on to our next topic, that is the truth table. Okay. So now, does anyone know the concept of Boolean algebra, Boolean variables?
Yes, ma'am.
OR gate, AND gate, NOT gate.
Yes. So what are the outputs in the form? Is it
0 and 1.
exactly zeros and ones? The outputs are binary.
Binary.
True or false?
Yes, sir.
It's just on and off. That's all. So okay, Boolean variables, that means it is either 0 or 1. It can be only 2. In those cases, if you have say 2 sets of variables A and B, so how many combinations are possible?
4.
4 combination.
4 combinations are possible, right? If there are 3 variables, then how many combinations are
8
possible?
combinations.
8 combinations.
8 combinations are possible. So if there are n Boolean variables, then how many combinations are possible?
2 raised to n.
2 to
2
the
raised to
power n. Right? So far so good. Is there any doubt?
No.
Okay. Now, do you guys understand the concept of OR gate?
Yes.
Yeah.
OR gate. Okay. So if the answer is an OR gate, if the function is your OR gate, in that case, if your A or B is 0, what should be the output?
0.
What about the second case?
1.
1.
What about the third case?
1.
1.
And fourth?
1.
It's all 1.
Okay, so the output is 0, 1, 1, 1, right?
One.
If it is an OR function. If I define it as a negation function, negation of OR function, then what will it be, the output?
1 0 0 0.
0.
1, 0, 0, 0. Acha. If I define it as an AND function, in that case?
0.
1 1 1.
0 0 0 1.
0 0
What should be
0,
1?
right? So similarly, I can have variety of functions which I can describe. These are very well-known functions which I just mentioned here, but you can have n number of functions, any possibility, right? You can have any such possibility, but such possibilities cannot be infinite, right? There will be a finite value of combinations that are possible in all of the scenarios. So how many maximum such functions can be made? See, ultimately it is binary, 0 or 1, right? So how many such functions can be there?
The maximum outputs are coming 4 for every function, right?
Right.
So
So
we have to calculate based on that maximum 4 will be 2 raised power 4 in
yes,
these two cases.
exactly.
Yeah.
So it will be a value of
2 to the 4 to the 8 to the 16.
16, right?
Yeah.
So this is your truth table.
Okay.
This is your truth table, right? You can have all these combinations only. There are no other combinations that you can have. All the combinations that you can have through any function is covered
Yes,
in
sir.
this. You
Ma'am,
appreciate this?
what-
Is there any
ma'am,
doubt
can
here?
you repeat again, ma'am?
Yeah. Yeah. 2 to the raised to the power 2 to the power n.
Because there are four positions, and the variables which can occupy those four positions are either 0 or 1. So by permutation combination, if you go, you can have total 16 such combinations only. No such possibility exists apart from these. Any function that you define, any gate, any function, whatever you define, will be covered in this,
Exactly, ma'am.
right?
Perfect. Wonderful.
Okay, so covered in the case of, when you have two Boolean variables, A and B. If you had three Boolean variables, A, B, and C, then instead of 4, you would have 8 here. And if you would have 8 here, you would have 64 such values, right?
Correct.
Yes.
So
Right.
ultimately, if you formulate it into a formula, what is the formula for the possible Boolean functions for these number of variables? If you have 2 to the power n, combinations that are possible, then what are the number of functions that are possible? By functions, I mean these columns. How many such columns are possible?
Got
2
it,
to the
ma'am.
power 2 to the power n, right?
Got it.
Is there any doubt here how we came to this formula?
No.
Yes, ma'am, I'm having confusion now.
Go on, please.
How to get this to the power n, calculation.
Because it's binary.
Number of possible combination will be to the power n. That I'm guessing, ma'am. But
Okay.
how again to the power n, how it is possible, ma'am?
Because just okay, I'll go back again. So here you have 4, right? 2 to the power n is 4 because n
Right,
is
ma'am.
2, right? So
Ma'am.
how many functions were possible?
Functions, what do you mean by that, ma'am? So how many functions are possible?
Functions are the number of the combinations that you're getting. For example, we discussed OR gate, right? It's a function. It's a function. AND gate, it's a function. NOR gate, XOR gate, all these are functions, right? There can be n number of functions, but all those functions will be covered in the possibilities that you have. What are those number of possibilities? Only 16. You will not find, see, ultimately you have four positions, right, for output. In any of the scenario, if you see, I have A and B, and I want an output. How many such positions are to be filled? 4. From the combination of this 0 and 0, I have to generate what is the output here. From the combination of this 0 and 1, I have to generate what is the output here. From 1 and 0, what is the output here? And from 1 and 1, what is the output here? So how many outputs are needed? 4. 4 vacant positions to be filled in the form of some function that I described, right?
Yes, ma'am.
And those 4 positions cannot have any other value than 0 and 1,
Yes, ma'am.
right? So
Yes,
no matter what function I define, it will be covered in all these values. Any permutation of 1 and 0 that you want for all these 4 positions are covered in this entire truth table. Any function that you define,
okay, ma'am.
right? So if that is covered in this whole table, then whatever function in any scope or any domain that you define, if it is covered, then what is the maximum number of such functions that you can define?
16.
16. And what is 16 in relation to this 2 to the power n,
That will be, ma'am. To the power n.
right? Clear so far?
Okay, ma'am. Thank you.
Yeah, so is anyone having any doubt here in this truth table?
No, ma'am.
No? In that case, we will move to the next question in your assignment. So how many Boolean functions are possible with n features? So if there are n features, how many such, but I'm not talking of Boolean functions, I'm asking of how many such variable combinations are possible. What will be the answer?
First one.
No. I'm
2
not
raised
asking
to
what is the answer of this question.
2 power n, ma'am.
2 power
2
n.
power.
But what is the question here? Not Boolean variable combinations. It is asking you Boolean functions. So it is 2 raised to the power 2 to the power n. That is option number A. This is your answer.
Yeah, that's the first one.
So this
Okay.
is the answer is the first one, right? So far
Right.
clear?
Yes, madam.
Okay, good. So now we will move to the concept of logistic regression. So before starting that, I will briefly come and reiterate what we discussed in simple linear regression. So in linear regression, we had this form, right? Y equal to mx plus c. Is there any doubt here why we had this form? Because this is the equation of a straight line. So any linear regression problem, we will try to associate it with this equation. Is this part clear?
Yes, ma'am, it is already clear.
Okay. In that case, uh, what about this? Forget what is written here. What do you understand by this? Is this an equation of a linear form?
Yes, ma'am.
Why do you say that?
It is having that multiple variables, and it again we have m1 x1 these variables.
Yeah, it is having multiple variables. And do those variables have any power associated with them?
No.
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 So wherever you have this variable x1, x2, x3, it's in the linear form. It is
Right.
not raised to power 2 or 2 by 3, any fractional power or any, logarithmic term, any such thing. No. It is in the linear form. But it is not a single variable problem now. It is a multi-variable problem now, right? You have multiple factors associated with it, but those factors are having linear dependencies. They have a coefficient, but the power associated with your variable is 1.
Linear.
It's linear, right? That is why you say linear regression. But now it is not simple linear regression, it is multivariable linear regression. Is it clear?
Yes, ma'am.
And actually, most problems, if you have a linear trend also, it will be multivariable linear regression, because there are so many parameters to consider, right? For example, if you consider the example of price of a house. So price of a house may depend on the location where it is, right?
Right.
It may depend on the number of bedrooms that is there in this house. It
Area.
may be a 1 BHK house, 2 BHK, 3 BHK, right? It may depend on the area, square feet,
Correct.
right? It may depend on the number of years that the house has been built. So there are so many factors associated with it. So if there are so many factors associated with it, you can have so many variables that you can tag it with. And all those variables, you may have a certain coefficient, positive or negative, whatever it may be, a certain coefficient associated with it. And that may define the total value of your house. It is possible, right? So in that case, you cannot have a simple one variable problem. You will have number of variables to deal with, and taking into consideration all those variables, you may have to define the total value of your output. So we will try to simplify this, because this is a very long way to calculate. So if you want to simplify this in the form, that you can do in the form of vectorization. What is vectorization doing? It is simply taking all these values and putting it in the matrix form, because matrix operations are much easier, right? What is it doing? Now if you take the dot product of these two matrices, you will ultimately get this only, right?
Right.
Is there any confusion here, anyone?
No.
So in that case, if you are multiplying this and getting this form, then you may represent these in the form of vectors like this, right?
Yes.
So representation of this multivariable linear problem in the form of vectors is called vectorization. So far clear? What have I done? I've just changed the way I'm representing the same problem. So far I have not done any operation as such. Just change the form in which I'm presenting my data. Instead of a linear form, I'm just presenting it in the form of vectors now, just to ease the calculation. So far clear?
Yeah.
Okay. Now if that is clear, then if we want to rewrite this, because this is of the form y equal to mx plus c, because this is the popular way we write the linear equation. But in ML, if you have to understand what this m is and what this c is, so basically we write it as y equal to wx plus b. where W are the weights and B is the bias. So suppose like I quoted the example of these price of the house, for example. So the price of the house may depend on, say, the number of floors there are there in the house. So if it is associated with the number of floors, so that may be your x1 variable, and that may have a coefficient of, say, zero point 0.1 times. Okay, so your m1 is 0.1 and your x1 is the number of floors. Okay, similarly, there may be some coefficient, say 2, and m2 value is 2, and x2 is the number of bedrooms in the house, right? So twice the number of bedrooms is the dependence of your price on the number of bedrooms, and so on and so forth. You may have any value associated with your coefficient, and your variables, these may be x1, x2 and x3, and so on and so forth. Now these values that they are associated with, these, the weightage that you give to any variable, those are your weights. Some variables may affect the price more, they have more weightage or higher value of coefficient as compared to the other variables which have less weights or less impact on the total output that you have. So now do you understand what these coefficients are? What do you mean by weights?
Yes, ma'am. Ma'am, just one thing, like you said about price of the house and various weights determine how each factor or each variable should be taken. How how do we compute the values of those weights? If you can share one example.
Yes, so that will be covered in logistic regression. We will come into that in the future
Okay.
classes, but
Okay.
this concept should be clear in the beginning, that what are weights. We will be discussing that. We will be coming to that. No worries about that. Anyone, any more confusion? Why these are called weights?
Clear, ma'am.
Weights are okay, ma'am. Like weights will be also using in MLP form, right?
Yes.
So, what can you explain bias one more time?
Yes. Now, bias is, see, if you have these, suppose all these factors, if I take it to be 0, will my
Okay.
price be 0?
Not.
No. So there will be some base price. It is possible that it may have a certain value associated with it.
Mm-hmm.
There are certain other factors which may be taken as a constant, or there are certain other considerations which are not accounted for. So in that case, those will be assumed as a constant factor, and that will be called as a bias associated
Okay.
with that model.
Got it, ma'am.
Okay,
Yeah.
you may try to consider as many factors as possible, but it is still possible that some other factors are still unknown or not taken into consideration,
Correct.
but those will add up to your output. And since they will add up to your output should already have a pre-existing value associated with it,
Mm.
right? And that
Yeah.
value is the bias associated with your model.
Yeah. Got
Right?
it.
For example,
So,
yes, someone is
no,
asking
just
something.
wanted to ask, like you mentioned that the constant values or the things which are constant across all the things, all the cases, we consider it as bias.
Right.
So, considering the example that you take of price, predicting the price of the house, so something like stamp duty charges or registration charges, which are constant because they are
possible.
government decided. So
Yes,
that
it
can
is
be considered as
possible.
bias.
That is possible.
Okay.
That is possible.
Thank you. Yeah,
Okay.
like there are so many other factors, even the what material have been used, material cost, and everything, so and so.
Yeah, there will be some constant value which is not nullifying the whole output, because of though if those factors are not taken into consideration, then the price will come into 0, right?
Right.
So that is not the case all the time. It may be 0. It is possible. See, this is just an example that I quoted, that the price of the house, but there may be so many other functions, and it may so happen that your C is 0, your bias is 0. It is possible. It is very much possible. In that case, the value of your B will be 0. You understand why we call it as weights and bias now, right?
Yes.
Okay, so in that case, now if you understand, so we will move from this representation to this representation now, fourth. Okay, so you should appreciate this representation from here on, right? So when we say this, it is a form of linear regression, but it is not necessarily simple linear regression. We are basically referring to multivariable linear regression. It is of the form y equal to mx plus c, but now your x is not just x, it is denoting this whole set. Except c, this whole set it is covering, right? So that is the only difference, that you, when you move from this to this, and this representation is the one we will be taking on here on, right? So now that you've understood this, we will move to what is logistic regression. Okay, now understand that regression is, a continuous value, and your classification is discrete set of values. Particularly if we talk of binary classification, then it is either 0 or 1. Okay, there are only two options in binary. So now, if we want to move from regression to classification, then what we do is we try to take the input from the regression values, and we feed a function such that we get the output in the form of probability. When you get the output in the form of probability, it will be a continuous set of values between 0 to 1. Okay, your outputs will be in the range of 0 to 1. Now once you get your value from 0 to 1, we feed a function such that if the value is greater than zero point 0.5, then we designate it as 1, and if the value is less than zero point 0.5, we designate it as 0. Now have you moved to classification?
Yep. Yes, we
Yes.
zero and one.
And you started from
regression,
right?
Yeah.
So you started from regression and you ended in classification. Is this part clear?
Right. Correct.
And you did that how? Simply by taking the probabilistic data.
Right.
For example, I feed thousands of input data, wherein I have images of cats, I have images of dogs. Okay, and now I feed a new image to my machine, and it gives me an output that it is possible that this is 30% cat. Okay, and it's a binary classification because I've only fed cats and dogs. There is no third category that I've fed to my machine. So now if it says 30% cat, now this probabilistic data, if I transform to binary, what will be my output?
Zero.
Zero. So what will it classify it as?
No.
It is a dog.
Logistic.
Do you understand the example? Should I repeat this part again?
Yeah.
Okay. See, I fed
Ma'am,
thousands of training data to my machine. Yes, go on.
Ma'am, you are feeding the data of dogs and cats. It is itself is a classification type of data. What you are need to feed a regression type of data, no? Where is the continuous values are there, and then you need to classify into two categories.
No, when you no, this is not. This is okay. Yes, you are right. But I have not fed regression type of data here. I am just talking of probability for now. See, there are three steps: regression, regression to probability, probability to rounding off.
We got the point of how to rounding up the probability and how to classify.
Yes.
Only the thing that the example is not pertinent to this kind of scenario.
Yeah, you can say that because I've given a probabilistic kind of answer. Yes, because it is related to probability, how you convert probability to your this example. Yes. So if I have thousands of images of cats and dogs, and there are no other option, it is binary, cats or dogs, and on that basis I'm getting a probabilistic data, right? I'm not getting, my machine is not directly reading it as cats and dogs. I'm not categorizing directly. What I'm doing is I'm getting the probability data. What is the probability of this being this, right? So if my machine is giving me an output that this is 30% similar to this category, then what will it read it as? Dogs, right?
Yes, ma'am.
Got it.
right? So that is how you convert from probability to your binary classification. Now coming to your regression part, if you have these weights and bias associated with it, there is a particular, we will be discussing in the next class because of dearth of time, but there are four such functions that we will be discussing here, out of which the most used is ReLU function. So we will be discussing that in the next class, how you convert your regression data to a probabilistic data, and from your probability data how you convert it to classification data. So we will be getting into the intricacies of logistic regression in the next class, but for now you should be able to appreciate how you vectorize your problem statement, and how from your vectorized problem statement you come to this concept of logistic regression. And now hereafter we will have we will have this, and we will also have our loss function defined, and from the definition of loss function we will be optimizing the weights and bias value, and after each training iteration the values of weights and bias will get modified, and once there is a constancy in your loss function values, then we will say that the model is trained, and then we will take that as the optimized model to work upon. So it is uh, the first value that we initiate is just initialization. We take an arbitrary value of weights and bias, and then we go forth with the iterations, and based on the optimization of your loss function we will be changing the values of weights and bias till we optimize this actually. So this cycle goes on and on actually, and then we come upon to a validated model, and that model we take as the trained model. So those we will discuss in the next class, but for now you should be able to read these equations, and you should be able to appreciate what you mean by multivariable linear regression, what you mean by vectorization, and what you understand by the concept of logistic regression. So is there any doubt in these three things?
No, nothing from me.
No, I'm clear.
It's clear, right?
Ma'am?
Is there any doubt? Did someone
Yes,
say
ma'am.
something? Yes, go on.
Ma'am, we can simply plot the y equal to mx plus c line on the graph, but when we try to plot the second line, there we have multiple features. So how do we do that?
So actually, this is a single variable problem, and there is a single output. So it can be plotted on 2D, right? So it is very easy to picturize. But if you want to visualize something like this, so you have n dimensions. The human brain is not capable of perceiving beyond 3 dimensions, right? So you cannot actually picture it virtually, but hypothetically speaking, it's a n plus 1 dimensional. I don't know what to call it, hyperspace, wherein you will have all these coordinates of x1, x2, x3, x4, xn, and there will be one more coordinate of y. So that will be
Okay.
the space actually that you are talking of.
No, I got it. Yes, thank you. And I want to appreciate you that I have interview last week, and in which the interviewer asked me what is the difference between logistic and no. So the question was, why do we call logistic regression as regression or classification? So thank you for clarifying.
Okay.
I got the probability term is introduced. So
Okay.
we can convert the continuous value into probability.
Right.
Thank you so much.
Okay.
Hello.
Yes,
Ma'am,
please.
you're talking about weight and bias, right, ma'am? So
Yes, weights and bias.
weight and bias we learn in artificial neural network, ma'am. There also we learn about weight and bias. Then what is the difference between machine learning and ANN now? Here also we are considering weight and bias, ma'am.
See, weights and bias are a particular concept. It may be associated with this or that.
Okay.
So that is not like weights and bias do not mean different things in different contexts, whether it is machine learning or artificial intelligence.
Artificial neural network, ma'am.
Yeah, in both the cases, when you talk of weights and bias, it means the same thing. The concept does not change in either of the scenarios. Are you confused with what these mean? Like, have you understood what weights and bias mean, or you want the contextual differentiation as such?
That differentiation I want to know, ma'am.
No, no, there is no such difference as such. When you refer to weights and bias, in both the scenarios, we are talking of the same thing.
Okay. And ma'am, when will be the next session about bias and variance? That I also want to know.
Variance I will be covering in the next class. There will be a slide on that, as I mentioned. So yes, in next Monday's session. Yeah.
Thanks a lot, ma'am.
Ma'am, can you discuss polynomial regression also along with this?
Okay, I'll make a note of that. Polynomial regression. Okay.
That's great.
Okay. Any more suggestions?
Can we have 2 sessions from you in a week, ma'am? Your sessions are really great. Super.
Okay. Thanks. That's really that's really nice.
Maybe Wednesday once or Thursday once. That would be great, ma'am. Evening time is fine. Like most of the people are free during this time. So 6 to 7, same time, Wednesday.
Okay, I'll try to figure it out. Actually, my weekdays are fully packed with research work and also.
Yes.
So yeah, okay, I'll check that. If it is possible, then I'll definitely, whenever it is possible, I will float a link and I will get going.
Just let us know. We will join at that time.
Yes. So that is all.
Yeah. Cool. Thank you, ma'am. Thank you.
Thank you.
Okay.
Thanks a lot.